So continuing to talk about parallelograms, the next step is called a rectangle. And rectangles are parallelograms that have four right angles. So by definition, all four angles are right angles. That's what's specific to rectangles. The rest of this information, opposite sides are parallel and congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. That's all information from parallelograms. So, our next theorem, Theorem 613, says this. If a parallelogram is a rectangle, then its diagonals are congruent. Okay? So essentially what that's saying is, if we have a rectangle, JL is the same as MK. Those are going to be the same length. They're congruent. So let's look at an example of one. It says a rectangular park has two walking paths as shown. If PS is 180 meters and PR is 200 meters, find QT. So QT is this value right here. Well, since we know that PQRS is a rectangle, okay, since we know PQRS is a rectangle, we know from theorem 613 that we just talked about that PR is going to be congruent to QS. Okay? So that means that if PR is 200, then QS is going to be 200 meters as well. I like that. 200 meters right there. Okay? So we know the whole thing is 200 meters. Now, we also know, since it's a parallelogram, rectangle is also a parallelogram, that we know that the diagonals bisect each other. So this right here, this point T, is halfway between QT and TS, halfway between QS. So that means if the whole thing is 200, then QT is going to equal 100 meters. Here's our guided practice problems for example 1. The video has stopped. You can try these problems now. Now we can also use our properties of rectangles and algebra to find missing values. So it says quadrilateral JKLM is a rectangle if the measure of angle KJL is 2x plus 4. So KJL would be this one right here. And it says the measure of JLK, K would be right there. So find the value of x. So this is what we're going to look at. It says right here, or we know that that has to be a right angle, right? And our angle KJL and angle JLM right there are going to have to be equal to each other. And we know that because it's a transversal that cuts the two in half. Those are alternating interior angles, so they're going to be equal to each other. So we know that angle MLJ, which is this one right here, plus angle JLK are going to add up to 90. Well, since we already know that KJL and MLJ are equal to each other, we can just substitute it in. So I'm going to say angle KJL plus angle JLK is going to equal 90. Okay? So we know that those are equal to each other. So what I can do is I can substitute my values in with x in it. So this would be 2x plus 4 plus 7x plus 5, and they're going to equal 90. Now it's just a straight algebra problem. I combine my like terms. 2x and 7x is 9x. 4 and 5 is 9. That's to equal 90. Now I just solve it. Subtract 9, and I get 9x equals 81. divide by 9, divide by 9, x equals 9. And that's what they wanted us to find. Now we could also find the value of the angles, and all we would have to do is plug 9 in to them right there. Okay, so our guided practice says refer to the figure. If JP is 3y minus 5 and MK is 5y plus 1, find the value of y. And you'll do that right now. So our next theorem, theorem 614, says diagonals of rectangles. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So now we know if we have two diagonals, we can find the length of those, and if they are the exact same, meaning they're congruent, then it's going to have to be a rectangle. So, example 4, rectangles and coordinate geometry. It says quadrilaterals PQRS has vertices of those right there. Determine whether PQRS is a rectangle by using the distance formula. Okay? So, distance formula. Just a reminder, distance formula is this. The square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared as well. Okay, so we can use that. We're going to have to use that a couple different times. So what we'll do is we'll find the distance of PQ. We'll find the distance of RS as the two opposite sides of our rectangle. So if I labeled it right here, okay, PQRS. So let's begin by finding PQ and RS. Let's find those. So PQ, its distance is going to be negative 5 minus 1 squared plus 3 minus a negative 1 quantity squared, which equals, if I put it all into my calculator, the square root of 52. Now let's find the length of RS. Okay. Finding RS, that's going to be negative 1 minus a negative 7 squared plus negative 4 minus 0 quantity squared. Put that all into my calculator, and I also find it's the square root of 52. So these two values are the same. That's good. Now we're going to try and find QR and PS. So PS is going to be the length, negative 5 minus a negative 1 squared plus, negative 7 squared, and then 3 minus 0 quantity squared. Put that all into my calculator and simplifies to the square root of 13. Now let's find the length of QR. One minus a negative 1 squared plus negative 1 minus a negative 4 quantity squared. Put it in my calculator, I get square root of 13. Now if I went too fast for you, I apologize, but you can go ahead and pause the video, put these in your calculator and figure out, just check to make sure that I'm correct. So that's good because now we know that PS and QR are the same lengths as well. So now we know all four sides are the same. That's good. It means it's a parallelogram. Now, if we want to use that information to figure out if this is a rectangle, then we have to know if PR and SQ are the same length as well, congruent. So I'm going to do the distance formula two more times. So I do PR first, and PR then is going to be the square root of negative 5 minus negative 1 squared plus 3 minus the negative 4 squared. I put that all into my calculator, and I find that to be the square root of 65. Okay? So now, let's find the other diagonal, QS, find its length using the distance formula, and see what we get. And so that's going to be 1 minus a negative 7 squared plus negative 1 minus 0 squared. I put that into my calculator. So first one is 8 squared is 64. 1 squared is 1. 64 plus 1 is the square root of 65. So you'll see that both of them are congruent. So since QS and PR are congruent, then obviously this is a rectangle. So is this a rectangle? PQRS is a rectangle. Our guided practice problem right here says determine if this is using the slope formula. Okay? So slope formula, if you want them to be congruent, what you're going to have to do is you're going to have to find the length of all the sides to make sure that JK and LM are parallel. And once you do that, if they have the same slope, then it's going to be a parallelogram. And then you can find the distance of the diagonals to see if they are rectangles.